Before we start, I recommend that you watch my video about trigonometric formulas and identities using the hexagon method here. If you have already watched it, then we can begin. First, let's divide the hexagon just like this. Let's start with the derivative of sine x. The technique is simple. If the function is at the top, we move horizontally. Sine, we move horizontally. That is cosine x. How about for derivative of tan x? If we are in the middle, we move down and then we square it. So here tan, then we're going to move down, then we're going to square that. So that is secant squared x. How about for the derivative of secant x? The derivative of secant x is equal to, if we are at the bottom here, then when we first copy the function, copy this function secant x, then we move up here tan, so that is tan x. Now let's go to the right side. The rules are the same, but we add a negative sign here. Example, the derivative of cosine x is equal to, since cosine is at the top here, we move horizontally here. But we first add negative. So that is negative sine x. How about the derivative of cotangent or cot x? Since it is in the middle, we move down here. We move down and we're going to square that. So that is negative cosecant squared x. And finally, for cosecant here, the derivative of cosecant x is equal to, first we're going to copy first this, then we're going to move up, or move up. We add negative, then copy cosecant x, then move up cotangent x. So remember this, if it's at the top, move horizontally. If it's in the middle, move down and square. If it's at the bottom, copy first, then move up. If it's in the left or on the left here, that is positive. If it's on the right here, that is, we add negative. Let's answer this example. Number 1, the derivative of 1 all over cosine x. Remember our hexagon here, since we have here 1, if we place 1 and we have secant and cosine, since they are opposite, secant x is equal to 1 all over cosine x. So d over dx, that is secant x. And we all know the derivative of secant x is what? First, we're going to copy secant x, then we move up tan x. Example number 2, the derivative of sine x secant x is equal to, since we have here sine and secant, remember our hexagon, if we take two functions in the hexagon and we multiply them here, the result is equal to the function in between them here, that is tan. So d over dx is equal to that of tan x, and the derivative of tan x is equal to Since it is in the middle, we're going to move down. Then we're going to square that. So that is secant squared x. Example number 3. The derivative of cotangent x sine x all over cosine x. Let's circle this. Since that is tan, since we have here tan, if we move counterclockwise, that is sine and cos. Remember? So t over dx is equal to cotangent x multiply to tan x. And since cotangent and tan is multiplied, we're going to have 1. Remember? So that is, remember, you can prove that by using this tan x equal to 1 all over cot x. If you multiply tan and cot, we're going to have 1. So that is d over dx of 1. So that is 0. Example number 4. D over dx of sine x multiply to cotangent x is equal to, that is sine here, sine, then we have here cot. If we multiply them, we get this cosine x. So d over dx is equal to cosine x, and that is, since that is in the right side, we're going to add negative, then we move horizontally. So that is sine x. Example number 5. D over dx cos squared x plus sine squared x is equal to, remember our hexagon, if we divide this from left to right, from left to right, from left to right, so that is sine squared x plus cos squared x is equal to 1. So d over dx, that is 1, so it's equal to 0. 6 d over dx of cosine x, that is negative sine x. Number 7. D over dx of cotangent x, that is negative cosecant squared x. Remember, if we have here cot and we're going to move down and we're going to square that. Sample number 8. The derivative of cosecant x is negative. Here cosecant x, sorry. Copy cosecant x, then move up cotangent x.